Today's lesson is solving quadratic inequality. So previously we solved quadratic equations by graphing the related quadratic function. A similar method can be used to solve these quadratic inequalities. Starting off with just an example, use the graph to solve the inequality x squared minus 4 greater than or equal to 0. So yes, that is a greater than symbol there. And if I'm talking about anything greater than 0, I'm referring to where it would be positive. So to solve the inequality, graph the related function y equals x squared minus 4. And that's been done over here to the right. They graphed y equals x squared minus 4. And if we're considering where it's positive, look at this first comment bubble. Look for points on the graph where the value of the function is positive. And we are considering the y values. So anywhere that is above the y-axis. So let's highlight here, we're looking at these two segments that are above the x-axis and therefore where the function is positive. It says that the graph of the function is positive over the intervals x is less than -2 and where x is greater than 2. We can see that we have those x-intercepts at -2 and +2. So on this left side, everywhere where x is less to the left of that -2 is where the function keeps going above or positive on the y-axis. And on the other side, we have anywhere where x is greater than +2. So x squared minus 4 greater than 0 occurs when x is less than -2 or where x is greater than 2. That is our solution. And we can also represent it on the number line. If you recall doing compound inequalities, we have open circles at -2 and +2. We're going to the left on that -2. We're going to the right on that +2. And that's an or compound inequality with those that looks like oars on a boat, or compound inequality, making a note there. So quadratic inequalities can be also solved algebraically using factoring. Let's look at those steps below. So let's use number 1 as we walk through those steps. We're going to solve each inequality algebraically. Number 1 is x squared plus 8x plus 15 is less than 0. Our steps here, we're going to set our inequality equal to 0 and factor our trinomial. Let's go ahead and do that now. For number 1, x squared plus 8x plus 15, we're just going to change it to equal to 0 so we can factor it. I want to consider the factors of 15 that add up to 8. So not 1 and 15, 3 and 5? Yes. So there's my winners, +3, +5. I can build those factors using those numbers, x plus 3, x plus 5 equals 0. Step 2, set each factor equal to 0. So x plus 3 equals 0, x plus 5 is equal to 0, and solve each of those. So on the first one, we're getting -3. Second one, after I subtract 5 from both sides, -5. Step 3, use the inequality symbol to determine if the solution will be represented by an and or an or compound inequality. So going back up to the original problem, it was less than 0. So think about the graph. If we graphed a parabola, anywhere less than 0 would be a lower segment and it would only be that one segment continuously. So it is going to be less than and. So thinking about our number line, we have -5 on the left side and -3. If we have an and, we're shading right in between. So -5 less than x less than -3, written as a compound and inequality squished together, is our final answer. That is where this quadratic is less than 0, right between that segment, -5 to -3. Let's try again with number 2. X squared minus 3x minus 40 is greater than 0. So if you recall, this is going to be an or compound inequality. Let's go ahead and set it equal to 0 and factor, considering the factors of -40 and trying to find the pair that adds up to -3. So 1 and 40, 2 and 20, 5 and 8. There we go. Positive 5, negative 8 is going to work out for us. So let's put those into our factors. X plus 5, x minus 8 equals 0. Going to set each of those factors equal to 0 and solve them, giving us x equals negative 5 and x equals positive 8. If I'm thinking about my number line, we already said this is going to be a greater. Where is this parabola? Greater or above the x-axis. Where is it positive? So there's going to be two segments connected with the word or. We have negative 5 and we have 8. It's going to be shading opposite directions like the oars on a boat. So our final answer is going to look like x is less than negative 5 using that conjunction, or x is greater than 8. There's our final answer in the box. X is less than negative 5 or x is greater than 8 would be the two segments where this quadratic is greater than 0. Number 3, go ahead and set it equal to 0. X squared minus 16x plus 60 equals 0. I'm going to factor, looking for the factors of 60 that add up to a negative 16. I'm already pulling out in my mind 6 and 10, making them both negative. Multiplying two negatives make a positive 60. Negative 6 plus negative 10 is negative 16. So using those values to make my factors, x minus 6, x minus 10 equals 0. Solving each of those, setting them equal to 0. We're going to have x equals positive 6 and x equals positive 10. We had a less than or equal. It's still less than and. And we're talking about less than. So where is this going to be below or negative on the y-axis? So just that little segment, we're going to write it as an and compound inequality. On our number line, we have a 6 and we have a 10. It should be shaded right in between. So let's write 6 is less than or equal. That was our original inequality symbol. X less than or equal to 10. Final answer. And last one, I'm going to go ahead and set x squared plus x minus 20 equal to 0. Looking for the factors of a negative 20, that would add up to a positive 1, 4, and 5. I think so. Let's do positive 5 with a negative 4, so it adds up to that positive 1. X minus 4 times x plus 5. Set each of those equal to 0 and solve. I'm getting an x equals positive 4 and x equals negative 5. Let's see, our original inequality symbol was great or. So we should have an or compound inequality here. We're talking about where is the parabola above or greater than 0. So there's going to be two segments, again, combined with that word or. Considering our number line, we have a negative 5 and a positive 4. Oars on a boat, they should be shading opposite directions. So we have x is less than or equal to negative 5, or the other segment, x is greater than positive 4. There's your final answer, solving this quadratic inequality. So you can see a couple different areas where concepts that we've already studied are coming back into play. Those compound inequalities definitely are being used here to solve these quadratic inequalities. It seems overwhelming. We've been studying quadratic equations, but all we're doing is considering where is it above or below that x-axis. So guys, practice that. I'll see you in class. Have a great day.